Okay, be sure that your account is set up and open the GitHub page for ESP AWS IoT, because now we're going to clone this repository and we're going to use this command here. So let's copy it using this button, and then let's go to the workspace folder. And now right-click on the project folder, and let's go to Git Bash here, which is right here, okay? And then let me pull Git Bash into view. Now let's insert the command that we've copied and hit enter. And just let it finish. I'll speed up the video a bit here. Okay, now we can close Git Bash. And here is the ESP AWS IoT. So let's take a look. And this is the embedded C AWS IoT device SDK. So let's go in here and take a look around. You can find the include files here and the source files here as well. And if we go back to ESP AWS IoT folder, here you'll find the examples that you can get started with. And this is the subscribe publish example. And in the main folder, the file here is what I've based the code on in the resources. Okay, so now we'll continue in the Eclipse IDE. And now I'm just getting back to the project folder, because next we'll need to include the ESP AWS IoT into the build. So now let's switch over to Eclipse. And let's go to the CMake list file in the project directory here, and we'll tell CMake where to find AWS IoT. So here let's write set, and in parentheses, it's extra component dears. Okay, and then in quotations, it's ESP-AWS-IoT, and close parentheses, and then Control S to save. All right, now let's include the resource files. So have yours ready. Mine are right here, and I'll just Control C to copy them. And then let's go to the main folder and paste them in. And now you need to add the source file to the main CMake list file here. So now let's add it to the list, and that's the AWS IoT.c, and save that. Next, we'll need to go to AWS IoT and generate the certificates. But while we're here, let's create a folder for the certificates. So under the main folder, let's create a new folder and call it certs. And now we can head over to the AWS Management Console. All right, so this is the link here, which you can find in the resources, and we'll log in using the button here. Okay, so I'm a root user, so I'll enter my email address. And then click Next. Then do the security check. And now sign in with your password. All right, so this is the console home screen. And first off, I just want to point out that you can easily retrieve your account number here, which we'll need later. And also your region, which you can adjust, you can retrieve here as well. So now let's go over to IoT Core, which I've recently visited. And we can pull that up by searching IoT Core. And here, just follow the link. And this is the main page. And there's additional resources directly linked here. For example, there's an interactive tutorial here, as well as video resources, and a developer guide. Okay, so now let's get started and go to the Manage dropdown right here, and then choose Things. And now we'll want to go to Create Things, then choose Create Single Thing, and click Next. Okay, and in this step, we'll give the thing a name, and the name that we choose has to reflect how it's defined in the source code. So let's go over to the source code, and I'll show you where that is so you can rename it to your liking if you wish. Okay, so now let's open the AWS IoT header file, and this is the define, so go ahead and change it however you like, and I'll just stick with this one, so I'll just copy it, and I'll paste it as the thing name. And then we won't touch the additional configurations, so we can just click Next. And now we want to auto-generate a new certificate. Click Next. Now we'll create and attach a policy to the certificate, and I already have an old policy here, so we can just ignore that and click on Create Policy. Now just give your policy a name, and I'll call mine Udemy ESP32 Test Policy. All right, so we're going to create the policy document here, which will be formatted into JSON. And we could do that by going over to the builder. And just so you know, you can include all actions by including the asterisk, like so, and then include another asterisk as the policy resource. But we're going to be more specific, and let's first allow for IoT Connect. And the policy resource needs to be formatted as it's shown here. And I'll include a text document that you can copy from and adjust, or you can just follow my typing here. So first it's ARN:AWS:IoT:, and here you'll need to include your region, and I'll show you again where you can find it in a minute, and so I'll just type mine for now. And you can find yours from the drop-down here, okay? And it's on the right side there. And also, now you can copy your account number from here, because we'll need to include that here too. Okay, after the colon, just paste it. And this first part you can go ahead and copy, because we'll use it for the next policy statement. All right, and then next type client. Okay, and then we need to include the name of our thing. So here that'll be / Udemy_ESP32_test. Now let's add a new statement. So just use the button here, and we'll allow, and this time it's for IoT subscribe, and just follow me for the policy resource, and just paste the first part, and then type topic filter / and I'll show you where to get the topic from. So let's go over to the source code, and then go to the C file, and let's scroll down. And the topic name is right here. So let's copy that and go back to AWS IoT, and let's paste it like so. Okay, that looks good. And let's copy the relevant part, and then let's add a new statement for IoT receive, then paste the resource, and then its topic / and we need the topic name, so it's the same as before. So let's copy it from the previous resource, and let's append it for IoT receive. Okay, and this time, let's copy the entire field, and now let's add the final statement, and this will be for IoT publish. And then just paste the resource, as its contents are the same as the previous field. And then the policy document is complete. Okay, and then scroll down, and let's click on Create. And you have to be sure to give it a unique name. In my case, the name already exists, so I'll just change it. and then again click Create. So I'll go ahead and delete this old policy, and if you ever need to do that, you can select it and then click Delete, and then type Delete here. Okay, so now let's attach this policy, and to do that, we'll go back to the previous tab. Then we'll select the created policy to attach, and then click Create Thing. And here are the certificates and keys that we need to download. So first, let's download the device certificate. And then we also need the private key. And we also need the root certificate authority certificate. And we'll just use the RSA. So let's download it. And then click Done. But it actually wants us to download the public key too. So let's do that. Okay, and now we can move on by clicking Done. And just so you're aware, you can always view your certificates over here under the Secure tab. All right, so now let's add the certificates to the project. So let's open the folder. And here I have the project folder ready. And here's the main project folder. So I'll just set these side by side. Okay, now let's be sure that we select the root CA, as well as the device certificate, and the private key. And I'll just Control X to cut them, and then I'll paste them here into the certs folder. Okay, now let's go to the source file and take a look at how they're defined. All right, so here we have the root certificate, the device certificate, as well as the private key. And the embedded certificates are loaded from the certs folder and embedded into the application binary. So we need the file names to match these here. So let's refresh the folders so that the certificates appear. Let's refresh and expand the certs folder. Okay. Let's copy the root CA name. And I'll just bring the file names into view. Okay, now right-click and rename. And then let's just paste the name. And then click OK. And let's grab the device certificate name. Copy it. And let's right-click, rename, paste the name, and click OK. All right, now let's copy the private key file name and rename and paste. Okay. Now let's continue. Go to the main CMake list file here, and now we'll tell CMake to embed these files. And we'll do that using the following command. Say target, add binary data, parentheses, $, open curly braces, component, target, close curly braces, and then in quotes, we need the path, which is certs, / AWS root CA PEM, and it's text, and close parentheses. Then let's copy this line and paste below, and then just update the name of the file. Okay, then add the private key. All right, that looks good. So now let's go to the C file and go to the bottom of the file. And this function here starts the AWS IoT FreeRTOS task. And we'll need to add these defines to the tasks common header file. So let's go there. And we'll define for AWS IoT task. And first do the stack size. as 9,216 bytes. Then let's add the priority as 6, and then let's add the core ID and we'll make it 1. Okay, it looks good. Now let's save it and then go back to the C file, and now our defines are updated. Okay, and next, we need to build the project and generate the updated SDK config file. But first, I'll make sure to save the CMake list file that I forgot to save here. Okay, now that's saved. And before we build, let's first go to main.c and let's include AWS IoT.h. All right, then we want to call the task start function when we have a Wi-Fi connection. So let's go ahead and copy that function name, then paste it. Okay, so again, this task should only start when the ESP32 is connected to the internet, and that's why we want to call it here. All right, so also before we build, we need to increase the partition table sizes for the OTA slots, and I've included the partition table in the resources. So please have that file ready, and I'll show you where to include it. Okay, so with the latest IDF IDE installation, my IDF is now located in this location. So I'll just go to Frameworks, ESP-IDF, then go to Components, and then go down to Partition Table. And you'll want to replace your old partitions to ota.csv file with the one that I've provided. And I've already updated mine. So let's go ahead and take a look at that. And let's review this from the top. NVS here is the same. OTA data is the same. And this is the same. But here I've removed the factory app to make more room for the OTA slots. And I've maxed out both of them for my ESP32 rover. And that's it. And we could swap between these two OTA slots for firmware updates. Okay, now let's go back. And just be sure to update yours as well. Now we're going to build the project so that we can update the SDK config file for AWS IoT communication. So go ahead and build all. And this may take a bit, so I'll speed up the video now. And now let's open the SDK config. And go all the way to the bottom and open Amazon Web Services IoT platform settings. And now we need to update the AWS IoT endpoint hostname, which we can get from the AWS IoT account. But first, I'll show you where this variable is located in the source code. So in AWS IoT.c, go towards the top of the file and take a look at this variable AWS IoT MQTT host. This is the default MQTT host URL that is pulled from AWS IoT config.h. And if we hover, we can see that it's empty. So let's follow this definition, and we can see that this definition originates from here. So let's follow that. And this takes us to the SDK config.h file, and of course this variable is empty. So let's go ahead and update it. So let's go back to AWS IoT, and first let's go into the thing. Click on the thing and choose Interact, and from there go to View Settings. And here we have the device data endpoint. And here it tells us that your devices can use your account's device data endpoint to connect to AWS. Each of your things has a REST API available at this endpoint. MQTT clients and AWS IoT device SDKs also use this endpoint. All right, so that's exactly what we need. So let's copy that by clicking here. And then now let's go back to the IDE. So go back to the SDK configuration and paste it here. And be sure to save it. And then we can close it out. Okay, now let's build so we can test it out. And again, I'll speed up the video for this. Okay, now let's flash. And here I have a message that you've probably seen before. In this case, it looks like IntelliSense didn't recognize a variable in Wi-Fi app.c, so let's just proceed. And if I click on Wi-Fi app.c, now it goes away. All right, so now just let flashing complete. Okay, and now let's have AWS IoT.c in view and open a monitor. All right, so just give me a moment to connect the ESP32. Okay, so now I'm connected, and the callback function is called, and the AWS FreeRTOS task is started, and now AWS IoT is subscribing. And now I'm getting the messages logged right here. Okay, and let's see where this happens in the source code. So just follow me. And these are the sprintf messages into the C payload variable for quality of service 0 and for quality of service 1. And for quality of service 1, we're checking the error status, in which this error would imply that QoS1 acknowledgement wasn't received. All right, so now let's go to AWS IoT and view these messages there. Okay, in AWS IoT, let's go back to Things. And now just click into your thing. Now go down to Activity, then to the MQTT test client. First, we need to enter the topic filter, and the topic filter describes the topics to which you want to subscribe. And this is defined in the source code. So let's go to the IDE and follow me just up here. And that is our topic defined right here. So copy it, and let's go back and paste it here. And now let's go down to Additional Configuration and select Display Payloads as Strings, and then click Subscribe. And then you'll see the messages start to appear, and it may take a second or two. And there we go. Our test topic is alive, and the data from the ESP32 is populating right here. And the messages are populated at the defined interval from the source code. And we can set this as a favorite so that we can view it anytime we go to AWS IoT. So set it as a favorite here. And now let's test publishing to the topic. And here we'll just click Publish to publish this message. And that'll be for our topic. And the message payload will be published to this topic with a quality of service 0. Okay? All right, so now let's test it. And back in the IDE, we can see that it was sent successfully right there in our subscribe callback function. And that's where the message is logged into the console. So let's see that. And that is right up here. And that's from our subscribe callback handler, where the console messages are logged. Okay, so in the next lesson, we'll do a brief walkthrough of the source code, and also we'll expand it to include received signal strength of the Wi-Fi connection, as well as the temperature and humidity sensor data. All right, so I really hope you enjoyed this lesson, and I'll see you in the next.